Hello and welcome to my science tutorial. In today's video we are going to be looking at binomial expansion using the Pascal's triangle. So before we start, let's know what a binomial is. So binomial or a binomial is any expression containing two terms connected by an addition or a subtraction sign. So you can have a plus b, okay, with a certain power, let's say 7, can be said to be a binomial, okay. Then we can have maybe c plus d, but it's also a binomial. So this can be said to be binomials. Now, expanding these terms using multiplication can be very difficult at times and times consuming. So to actually facilitate the expanding of these questions, we tend to use the binomial theorem or the Pascal's triangle. Now in this video we are going to focus on the Pascal's triangle. Okay, so what do I mean by this is difficult? Assuming we have this example over here and we are to expand, come on, tell me, can you just keep multiplying a plus b then times a plus b till 7 times? It's very tedious, it's exhausting. After expanding this you feel like you've done a great job, but then by the time you realize your colleagues are somewhere else. So we need to find an alternative means of expanding this very easily, and that is what the Pascal's triangle and then the binomial theorem wants to help us achieve. So let's have a look at what the Pascal triangle is. Now the Pascal's triangle gives the coefficient in the binomial expansion to form a useful pattern. So the Pascal's triangle, it gives us the coefficient. So once we know the coefficient, we can continue with the expansion. What do I mean by this? Let's have the binomial here. So binomial, we have here the binomial. So we have the coefficient that we are going to get after using the Pascal's triangle, and then the expansion. So using the coefficient we can get the expansion of the form that we want. So let's have the binomial a plus x raised to the power 0. Now any number raised to the power 0 is 1, so we know, so the expansion will also be 1. Okay, the whole of this all will be 0, will be 1, sorry. Now if we have a plus x raised to the power 1, okay, this is just like a plus x, so the coefficient of this and this are 1 1, so we still have what, 1a plus what, 1x. Now from the second one it becomes interesting, which is the third over here, the second power. So we have a plus x raised to the power 2. So for this expansion we tend to repeat, we have 1 over here, okay, so we have 1 over here, so we repeat the 1. Now 1 plus 1, we add this 2 and write it at the middle, so it will give us 2. Then we repeat this one at the end again. So what this is telling us is that first we need to write 1, then the a term, then we square it, then plus, then we write 2 as the coefficient. Now this the power of the a squared terms will decrease, so we have a, then we introduce the x, then plus 1. Now the a has decreased from 2 to 1, so it will now go to 0, which is still a power 0 is still 1, so we ignore that, and then we write the x. Now the x, the power here was 1, so it will increase to 0, it will increase to 2, sorry. So we assume over here the x over here has the power of 0, so it is 1. So this is the expansion that we will get. If we have a plus x raised to the power 3, we repeat the 1 over here. 1 plus 2 give us 3. Now 2 plus 1 will also give us 3. Now we repeat the 1 again. So it means the expansion we'll be getting is what? 1a power cube plus 3a. Now the power will decrease 2. Then we have x plus another 3a. The power will decrease from 2 to 1. Then at the x, the power will increase. Then plus 1 x raised to the power 3. Okay, so if we have a plus x raised to the power 4, it will continue with the same trend. Okay, so we will have 1, then 1 plus 4 will give 1 plus 3 will give us 4, 3 plus 3 will give us 6, 3 plus 1 will give us 4, and then we repeat the 1. So the expansion will be getting there over here. You can see the pattern that it is following. So a power 4 plus 4, the 4 over here, a power 3, then we have the x plus 6 a square s square plus 4 a s cube, then plus 1 x power 4. Okay, so if we have a plus x raised to the power 5, guess what the coefficients are going to be? So they will be 1. We repeat the 1 plus 4 is 5, then 4 plus 6, sorry, will give us 10. 6 plus 4 will give us another 10, and then 4 plus 1 will give us 5, and then we repeat the 1. So this expansion will give us what? 1a raised to the power 5 plus 5a power 4x, then plus 10a power 3s square plus another 10 again, a square s cube, then plus 5a x power 4, then plus 1 x power 5. So this is the binomial expansion using the Pascal triangle. So the Pascal triangle is giving us the coefficient that we need, and then this is the expansion form. Now we need to know how to derive the Pascal triangle ourselves, okay, so that it can facilitate our work for us if we are doing it. So let's look at that. Okay, so let me get rid of this and let's solve one practical example. Sorry. Okay. Oops. Okay, so example number 1. So now we need to know that the Pascal triangle is only useful for n values less than 8. So what do I mean by that? So we have a plus x raised to the power n as the general formula. Well, for n values less than 8, so for n less than 8, the Pascal's triangle is useful. So from power 1 to power 7, the Pascal's triangle is really useful, but then above it, the Pascal's triangle is not really useful in that sense. Then we tend to use the binomial expansion rather to do that. So let's have our first example. So we have example number 1, 2x minus 3y raised to the power 3. Okay, so from here, let's compare this to the general formula where we have a plus x raised to the power n. So we can see from here, our a is what? Our a is 2x over here. Then our x over here, comparing to the general formula, our x over there is negative 3y. Mind you, the negative sign is attached to the 3, so we carry it along. Okay, and then our n is equal to what? 3. Okay, now the Pascal's triangle with the power 3, if you copied what the pattern we derived earlier, you can see it follows what? 1 3 3 1. Okay, so this will be the coefficients of the Pascal's triangle. So from here we can just go ahead straight and solve using this. So it means for the general expansion a plus x raised to the power n, what we are going to get is, for the binomial having the power 3, we will have 1a power 3 plus 3a square x, then plus another 3a s square, then plus 1s cube. So all we have to do from here straight is to put the value of a, x, and then a and x into this expansion, and then we get our answer. Cool. So we have 2x minus 3y over here cube will be equal to what? 1 into bracket, the a is 2x, so 2x cube, then plus 3 into bracket a, 2x squared, then our x is what? Negative 3y, so we have negative 3y over here, plus another 3, then our a is 2x, then our x is what? Negative 3y squared, then plus 1 into bracket negative 3y cube. Okay, so from here we can simplify. So this will give us what? 8s cube plus 2 squared times 3 will give us times negative 3 over here, don't forget this, will give us negative 36s squared. The s square is from here, then we have the y, which is from here, then plus 3 times 2 times negative 3 square will give us what? Positive 54xy square. Then plus, then we have negative 3 cube will give us negative 27, negative 27y cube. Okay, mind you, if you square and we have y attached or x attached, always remember to square it and then like have the powers over there. So our expansion for this example will be what? 8s cube minus 36s square y plus 54xy square minus 27y cube. Okay, so this is how we use Pascal's triangle to solve an example or to expand something. So yeah, let's look at another example to wrap up this tutorial. Okay, so example number 2, we have here 2x minus 3 raised to the power 4. Okay, so comparing this with the general form a plus x raised to the power n, we can see our a is what? 2x, and then our x is equal to what? Negative 3. Okay, and then our n is what? 4. Okay, so yes, then if you remember the coefficient of the Pascal's triangle with the power 4, we will be having what? 1 4 6 4 1. Okay, so once we know this is the coefficient, it means if we have the form a plus x raised to the power n, the expansion we are getting for the using the Pascal's triangle with the power 4 will be what? Here should be 4, so we'll be having what? 1a power 4 plus 4a cube x plus 6a square s square, then plus 4a s cube, then plus 1x power 4. So for this example, which is 2x minus 3 raised to the power 4, we just input the value of a and x over here and we get our answer. So we have 1 into bracket, the a is 2x, so 2x power 4 plus 4 into bracket 2s cube, the x is negative 3, then plus 6 2x squared, then negative 3 square plus 4 into bracket 2x, then negative 3 cube plus 1 into bracket negative 3 raised to the power 4. Okay, so if we solve this, 2 raised to the power 4 will give us 16, then the x2 raised to the power 4, then this will give us negative, so minus because of the negative sign over here. So 3 times 2 raised to the power 3 times 4 will give us negative 96 s cube plus 6 times 2 squared times negative 3 square will give us positive 216 s squared, then minus this 4 times 2 times 3 cube, okay, negative 3 cube will give us negative 216x, then plus negative 3 raised to the power 4 will give us 81. So this is our expansion using the binomial using the Pascal's triangle to solve this example. Okay, so I hope you learned something in this video, and I'll see you in the next video. Hello and welcome to my science tutorials. This is the second part of the binomial expansion. The first part we look at how to use Pascal's triangle, and in this example we are going to look at the binomial expansion or the theorem itself, and then how we use that to solve problems. So let's get started. So the general form of any binomial is given by a plus x raised to the power n. Okay, so the expansion for this using the binomial and not the Pascal's triangle is what? First we have the a value we have over here. Let me use another color. So the a value we have over here, we have the a raised to the power n, as the first term, then plus what we have as the second term will be what? We have the n becoming like it will now come to the, like it will not be first, and then we have the a, then we decrease the power of the n, so it will be n minus 1. Then we introduce the x, then plus, then we decrease the n over here, so it will be n minus 1, then a n minus 2. The power of the a will now decrease by 2 instead of 1. Then we have the x now being squared, then we divide this by 2 factorial, then plus n minus 1, n minus 2. This will now have n minus 2. Then we have a n minus 3 s cubed all over what? 3 factorial, plus you'll be doing this n minus 1, n minus 2, n minus 3, then a n minus 4 s4 divided by 4 factorial till you have what? X raised to the power n. So this is the general way of expanding a binomial using the theorem. Now remember, I made mention of some new terms over here, this and this. I said 3 factorial, 2 factorial. So what the hell is factorial at all? So factorial is very simple. So 2 factorial means what? 2 times 1. So 3 factorial implies what? 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. Hey, this one is too long. 5 factorial is what? 5 times 4 times 3 times 2 times 1. Exactly. So this is what we mean by factorial, and then this is the general way of expanding a binomial using the binomial theorem. So let's have a look at an example to see how we can apply this way of expansion to solve a particular problem. Okay, so now before we look at that, we have something that I really need to tell you guys. I think it will become useful some part in your objectives. So assuming you are asked to find, like without expanding at all, you are just asked to find the coefficient of the s cubed term, okay, in case you are to expand but you are not supposed to expand. How will you do this? So there's a general term used to find that. So we have n combination r, then we have a n minus r x r. Wait, before you start shouting what am I doing, please let me expand this for you so that you know what I mean, and then I will explain and you have a practical example how to use this. So this simply means we have n minus 1, n minus 2, okay, so we have what? N minus r plus 1, okay, all divided by r factorial, okay, then a n minus r x power r, okay. So I know this still sounds confusing, so let's have a look at a practical example so that we can appreciate what I mean by this. Okay, so let's have an example. They say find the coefficient of the s cubed term of the binomial expression. So we have 1 plus 3x raised to the power 12, okay, and we have to find the coefficient of the what? The s cubed term, okay. Now can you see that we have power 12 over here? So I'm telling you, if you are to expand this way to the power of 12 just because you want to get the coefficient of the s cubed term, it will be very long, I tell you. So you need to simplify this. So now to write this, let's take good note of this. So how do we now solve this problem? Well, this whole thing can be written as the n over here. Let's jot some terms down, okay. The n is the power, which is the 12 over here, okay. So the x, okay, if we have a plus x raised to the power n, okay, comparing this to this, okay, so the n is the 12 over here, and then the a will be the 1 over here, is 1, and then our x will be what? 3x. The x over here will correspond to the 3x over here, okay? And then our r is equal to the 3 that they are talking about over here, so it's the 3, okay? So using this, and let's put all of this into this, and then we'll get, so we have here we have 12 combination what r, which is 3. Then the a we have is where is our a? Oh, this is supposed to be a, sorry about that. So this is a, so our a is 1, so we have 1. Then the n is 12, okay? So 12 minus the r, which is 3, will give us 9, okay? Then we have our x here is 3x, so we have 3x. Then raised to the power r, the r is 3, okay? So this is what we will get, okay? Now I'm taking my time to explain everything so that you can understand to my maximum best. I'm explaining to my maximum best. Okay, so let's shrink this down, and then let's send it to the top. Okay, so if we have this, how are we going to do the expansion? This is very simple, because we are looking for they said the s cube term, okay? It means we need to have 3 terms in front of the s cube, okay? And that 3 terms, we will get it from what? The n minus 1, n minus 2, okay? So 3, we have 3 over here, okay? Then our a, which is this one over here, we'll still repeat that, 1 power 9. Then we have our 3x power 3 over here, this is 3, okay? So it means the 12 combination 3 is what? n minus 1, n minus 2, all divided by 3 factorial. Remember, we are dealing with 3 over here, so we divide by 3 factorial. So we have this. So all we need to do is to input the value of n, and then we solve this. So the value of n is 12. Now 12 minus 1 is 11, 12 minus 2 is 10, all divided by what? 3 factorial, which is 3 times 2 times 1, 1 power 9, then 3x raised to the power cube. So we expand this all, we will get what? 5940 s cube, okay? So with this, straight away we can say what? The coefficient of the s cube term that we've been asked is what? 5940. So so just get more example and then try it out, and I'm sure you'll be okay with this. It's really helpful in terms of objectives in an exam or in a class test. Now let's have a practical example how we are going to do the expansion during using binomial theorem. So example number 1. So let's expand 2 plus x raised to the power 7 using the binomial expansion. So first of all, we write the general term, okay? So we write a plus x raised to the power n, and then what is the expansion? So we have n, okay, a power n, then plus n, a power n minus 1 x, plus n minus 1, a n minus 2. The x will not be squared, we divide by what? 2 factorial, plus then this will increase, n minus 1, n minus 2, a n minus 3, s cube all over 3 factorial, plus, and it continues that way till you end up with a power of 7, okay? Alright, so having this general expansion, we can go straight away and expand and get our answer. So we have 2 plus x raised to the power 7. So what we will be having? We will be having the first term, which is the a. So we have 2 power 7 first, then plus, then we will be having 7, which is the n over here, then the 2, the a is the 2 over here, so we have 2 power 6, then we have x, then plus 7, then we have 6, there is the n is the 7, n minus 1 is the 6, then we have the a, which is 2, n minus 2, 7 minus 2 is 5, s squared, okay, then divided by 2 factorial, okay, then plus 2 factorial, so plus 7, 6, 5, okay, then we have the 2 raised to the power 4, the x power will increase by 3, we divide by 3 factorial, then plus, we go on, so we have 7.6.5.4. The dot are to represent multiplication. Let me just write it down to avoid confusion. Then times 2 raised to the power 3, okay, divided by 4 factorial, and then we have our x power 4 times over here, then plus 7, 6, 5, 4, 3. Okay, here we don't have the 3, so here we have to have the 3, then the 2 will come, then the power will decrease over here, we have 2, the x power will increase 5, divided by what, 5 factorial, then plus 7, 6, 5, 4, 3, 2. Then well, let me do this on another place so that we can see. So yes, so that expansion will be what, 7, 6, 5, 4, 3, 2. This is 3, 2, and then we have the 2 here is the power 1, then we have the x, the power will increase to 6, all divided by 6 factorial, then plus the last expansion for this, we have 7, 6, 5, 4, 3, 2, 1. Then the 2 will now have power of 0, which is still 1, so 2 power 0, x power 7, all over what, 7 factorial. Now this is beautiful. Let me get some space at the top over here so that we can continue. Okay. Okay, so all of this now will be equal to, now 2 raised to the power 7 will give us 128, then plus, if you expand 7 times 2 raised to the power 6 will give us 448x, plus the whole of this 7 times 6 times 2 raised to the power 5 divided by 2 factorial, which is 2 times 1, will give us what, 672s squared, plus 7 times 6 times 5 times 2 power 4 divided by 3 factorial, which is 3 times 2 times 1, will give us what, 560 x cubed. So the same way, all of this will be giving us a certain value. Let me quickly write them down. X power 4 plus x 84, x power 5 plus 14, x power 6. Now the last one, which is this, now let's take a look at something. This is interesting. So we have here 7 times 6 times 5 times 4 times 3 times 2 times 1. Does that sound a bit? Yes, that is exactly equivalent to 7 factorial, because I explained 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1. So the 7 factorial over here cancels the whole of this. Now 2 raised to the power 0 is 1. So 1 times x raised to the power 7 is still x raised to the power 7. So we have here x power 7. So that is how we solve an example using the binomial way of expansion. So I hope we are all here, so I can get rid of all of this, and then we solve the second example and we say goodbye. So example number 2. Now the example number 2, we are to expand 3 minus 2x raised to the power 5. So without writing the general way of expansion first, which is you need to write them down first, just so that you know, like, so let me just write it down. So a plus x raised to the power n will give us what? A raised to the power n plus n, a n minus 1 x. I'm sure by now you are getting used to the trend. N minus 1, then we have a n minus 2 s square, all divided by 2 factorial, plus n minus 1, n minus 2, a n minus 3 s cube, all over 3 factorial, and it continues. So we write our question, which is 3 minus 2x power 5. So we expand. So we have 3 raised to the power 5 plus 5 into bracket 3 power 4. Then our x term in this example is what? Negative 2x. So we write the negative 2x over here. Then plus 5, 4, 3 will have cube. Then negative 2x square. This is 3. Guys, be getting used to my 3. Then plus 5, 4, 3. Then the 3 will have squared. Then we have our negative 2x. We'll now have the power of 3 divided by 3 factorial. Then plus we have 5, 4, 3, 2, then 3 raised to the power 1, negative 2x raised to the power 4, all over 4 factorial. Then plus the last expansion for this will be 5 times 4 times 3 times 2 times 1, and then divided by 5 factorial. Then we will have our 3 will be raised to the power 0. Then we will have our negative 2x raised to the power 5. So let me get rid of this, and let me bring this up. Okay, so from here 3 raised to the power 5 will give us 243. Then plus, now 5 times 3 raised to the power 4 times negative 2 will give us what? Negative 810x, plus then the whole of this divided by 2 factorial will give us 1080 s square. Then the next one will give us negative 720 s cube. Then we will have 240 x power 4, then minus this, the last example again. 5 factorial is what? 5 times 4 times 3 times 2 times 1. So you don't need to input this into the calculator before you get. Just cancel this with this. 3 power 0 is 1. So this is also 1 times. So you just have to have like the last term, which is negative 2 raised to the power 5 will give us what? Negative 32. So 32. Then the x will have the power of 5. So yes, this is how we use the binomial expansion or the binomial theorem to solve a problem. So thanks you guys for watching. I hope you learned something, and then I will see you in the next video. So if you are new to this channel, kindly subscribe. I will post tutorial videos every single day, so be sure to subscribe and then turn on the notification button to get informed whenever we upload a video. Thanks for watching, and we'll see you in the next video.